Q&E Application Development Kit gives developers the possibility to extend Quantum Network Explorer with new applications. In this module, we will look at the file structure of the application and experiment. We will learn how the content of these files relates to what we see on the website. Some of the application files need to be developed based upon your application requirements. Others hold certain configuration needed by Q&E to run your application within the generic application runtime. Q&E ADK has commands added that create the files needed for an application and do some rudimentary validation of your application files. Next to these application commands, we have commands that create an experiment for your application. Validate the experiment files, run the experiment on the locally installed simulator, and show you the results of the experiment. We learned these commands in the previous module. In this module, we want to show the connection between the application configuration and the workflow of running an experiment on the Q&E website. With this insight, it's more clear what's needed to develop an application. First, let's discuss what the difference is between an application and an experiment. An application defines the template for an experiment. An experiment is a runnable instance of the application. An experiment roughly consists of the application itself and the values for the inputs needed for the application. These are the application input parameters and the definition of the network configuration parameters of the chosen network. The way what inputs are needed and how inputs and outputs are shown or used are defined or configured by the application. The actual input values given for that instance of the application when the application is run is part of the experiment. These input values may change for each experiment run. Said differently, the application defines the fixed part, the experiment adds the variable part. The application files and the experiment inputs are fed to the simulator running the experiment, giving the results which are fed back to the user input. Again, how the experiment results are presented to the user is defined or configured by the application. The actual result values that may change for each experiment run is part of the experiment. An experiment is gluing together the application, the user inputs, and, after running, the experiment results. We see this reflected in the file structures of the application and experiment. After executing the application create commands, we get the following application file structure. The application file structure consists of a number of configuration files in the config directory that configure how the application appears and acts on the Q&E website. Application source code, in our case a Python file for each application role in the source directory. These files implement the Quantum Network application we run. A manifest JSON holding the generic application data. Quantum Network Explorer is able to run experiments for totally different applications in the same generic user interface without changing the front-end and back-end code for each new application. We do this via configuration files defined in the directory config. In the next section, we dive deeper into the structure and content of these configuration files. First, we look a bit closer at the file structure of an experiment. After executing the experiment create command, we get the following experiment file structure. The experiment file structure consists of a directory called inputs where the relevant application files are copied to. These files are static and do not change for each experiment run. An experiment.json file for general experiment data and the inputs for the experiment run. These inputs typically are values for the input parameters of the application source code for each role and values for the selected network node parameters and network channel parameters that define the quantum network. For each experiment run, the contents of this file may change. For every Q&E experiment executed on the website, a predefined workflow is followed. The steps are the same for each experiment run, though the inputs and outputs for each step may differ depending on the selected applications and network. From the previous section, we know this is made possible via configuration files. To understand what configuration is needed and why, we go through the workflow of running an experiment on a predefined application called state teleportation. For each step, we will see what configuration is needed for the application and the experiment. We start with the first step in the workflow of running an experiment in Quantum Network Explorer, selecting the application. In the Q&E Community Application Library, the application name and description are presented. The values come from the application file manifest.json, more specifically the application section of manifest.json. The application is also saved in the experiment file experiment.json as application in a meta section. The simulator and its location are registered in the backend section. And the experiment name and description are saved in the root of the meta section. When we run the application, the network to run the experiment on has to be selected. The application can only run on networks that have greater or equal number of nodes as the number of roles defined in the application. In the application file network.json, the networks that are suitable to run the application on are defined as networks. They will be listed in a drop-down box. The network chosen is saved in the experiment file experiment.json as name and slug in the network section of the asset. In this case, Europe. As a next step, we assign application roles to network nodes by dragging the roles on the available network nodes. In the application file network.json, the roles that need to be assigned to a network node are defined as roles. The assignment of roles is saved in the experiment file experiment.json as roles in the network section of the asset. The network nodes and network channels for the selected network are configured next. Configuring the network is not part of the application configuration, but experiment configuration only. Network configuration is only needed to configure the quantum network for the simulator. When running on hardware, the network configuration is as is. The network configuration is saved in the experiment file experiment.json as channels and nodes, with all of its configuration parameters in the network section of the asset. For each network node, we define a value for gate fidelity. For each qubit for that node, we define values for relaxation time and dephasing time. For each channel, we define a value for elementary link fidelity. Then we configure the application input parameters. The application Python files, more specifically the parameters of the main function of these files, need inputs. These inputs are defined in a list in application.json. For each input parameter, a title and description are configured that are shown on the parameter input page. For each input parameter, also an input type is configured and the roles for which this input is needed. An input type may need one or more values. A float or int needs one value. A qubit as input type needs two angles, phi and theta. For each value, the name, minimum value, maximum value, default value, unit and scale value are defined. Scale value and unit are used for presentation purposes in the front end. While the application defines what input parameters are needed, the actual value for the input parameters are saved in the experiment file experiment.json. in the application section of the asset as values and roles for each input parameter. At this step, the experiment is completed and the experiment can be run. The experiment.json holds all the necessary user inputs. The next steps of the workflow are configured in the application only. For running the experiment, a Python file is defined for each application role. These Python files reside in subdirectory source and are named app_rolename.py. The input parameters for the main function match the input parameters defined in the previous step. The simulator runs these Python programs for each role and dynamically feeds the inputs coming from the experiment asset to the main function of the respective role. The results of the simulation are returned as return values of the main functions for each role. The return value is a dictionary with key value pairs. On the front end, process animation steps are shown. The animation of the experiment consists of a number of steps. Some of these steps are added by the simulator when some events occur in the application. For example, an EPR pair is created or a gate is executed on a qubit. The application developer can add animation steps by calling the application logger from the Python program to log some output for that role. These messages are added to the animation, prefixed by the role name. As a last step, the results for the state teleportation experiment run are shown. The actual results for each role of the experiment comes from the return values of the respective Python programs. On the website, the result is shown in a more readable form than the dictionary coming from the Python programs. How the results are shown is configured in the application file result.json as round result view. The round result view of the application can contain a number of blocks which are shown below each other on the website. A block consists of an output type and a title. Based on the output type of a block, extra configuration is expected as parameters. The web front-end implements a number of user interface components as output types that can be configured. Each output type needs one or more pieces of information defined as parameters to be able to present the result for this output type. For the output type text, the parameter content is expected. For the output type quantum state, a density matrix parameter is expected. All possible output types are described on the website. In the values for these parameters, a JSON path can be added to address a specific field in the output dictionary of the application file for a certain role. For example, this appsender.m1 address. This one addresses the value for the key m1 in the dictionary returned by the main function in appsender. With this, the QNE ADK Basics module concludes. We learned what is expected in the configuration files that make up the application and experiments to be able to run them on the QNE simulator. Up until now, we skipped the content of one important file type, and that is the application source code. The Python files for each role in the source directory of the application. These files implement the quantum network application we run. The next module will explain the contents of these files in more detail.